so now we'll move on to the concept of conditional probability. So, say we have, I'll draw a table. So, if it asks what's the probability of a male, we would say, okay, well there are 8 total males, and over 8 plus 5 plus 22, which is 8 over 45, right? But say we're instead told, okay, I'll tell you that it's a goat. Now what's the probability of it being male? Well, now you can completely ignore the sheep and just focus on, 5. There'll be 5 male goats and 30 total goats, so there'll be 1/6. And this is an idea of conditional probability. So we would write that as P of male, given that they're a goat. And this is equal to P of male and goat, P of male goat, divided by the probability of being a goat. And in this case, it would also equal N male intersect goat over N goat. And this is because if I draw a bit of a Venn diagram here, there's something a bit like this. So this is male, female, sheep and goat. And basically we're saying, okay, it's a goat. We know it's a goat. So we have already narrowed our thing down into this range. And now from there we're saying, okay, male and goat. So we're targeting this intersection here, which is why we have this intersection symbol. And quite commonly, and you can also use trees for this, and trees are particularly useful for certain reasons. And so this situation is, say, like someone offering their friend if they want to go to the beach or the park, and they might offer beach or park, and then the friend might accept or refuse. And then if you were to write in some probabilities here, say this is 65, 0.35, 85, 0.15, 0.3, 0.7. This here already is a conditional probability. This is already P except given beach, because the way a tree diagram works is we follow along. We know we've got to do the beach offering, which one, beach or park first, then they might accept or refuse. So here, beach already has happened. And it's likewise for this one. Here, park already has happened and park has already been offered. And obviously you can do things like to find the total probability that it'll accept 0.3 times 0.35 plus 0.7 times 0.85. And you could also reverse it. You could say P beach given refuse. So you would calculate the probability of refusal, which is, well, it's just 1 minus whatever this is. But you do that. But then you do the probability of beach and refuse happening. So 0.3 times 0.65. And with conditional probability, think about events that are independent. Say we're thinking A and B are independent. If we know that B's happened, if they're independent, that doesn't affect what the probability of A will be. And this is kind of, as we know, this is equal to P of A intersect B over P of B. And that's equal to P of A, right? And that's why P of A intersect B is equal to P of A times P of B. And again, there may be algebra involved. They may give you a probability and you have to work backwards to something else or whatever. Just do lots of questions and hold out for the videos that will come with this topic and its questions.